Hello everyone, welcome to another LearnEd tutorial video. In this video, I'm going to explain how we would solve this equation in the complex plane. So our answer is going to be in the complex plane, which means that it's going to potentially be a complex number. So something in the form, our answer for z will be in the form a plus bi, where we know that I is equal to the square root of -1. Okay, so the reason we know that we can solve this in the complex plane is because of this little part of the sentence here. So we've been actually told that z is an element of this big set C. So this special C represents the complex plane, which means that's the plane where the imaginary number I exists, and you can basically square root negative numbers. Sometimes you will be able to see a similar you might see a similar question where you actually say z is a subset of R. Now this is the real plane, and you should be very familiar with this one. That's the one that you've probably been working in your whole life so far. The real plane doesn't allow for square rooting negative numbers. In the real world, that doesn't make any physical sense. So in the real plane, this question would probably be a bit of nonsense. There wouldn't actually be an answer to this one in the real plane. In the complex plane, it's a different story because we are allowing negative numbers to be square rooted. Okay, so we're going to work through how to solve this, and now I'm just going to point out there are probably two main ways that you will see how you can solve this. One way, which is probably faster, but I wouldn't recommend it because of a big mistake. Two reasons. One is that there's actually a bit of a classic mistake that we'll illustrate along the way that students make when they use this method, and that's just solving algebraically. So I wouldn't recommend this one, but we'll go through it anyway because a lot of people do use it. The other one is, this one is factorizing it first. So factorize over C, so over the complex plane. So some ways of factorizing only work in a complex plane as well. Factorize over C and then solve. Solve using the null factor law. Okay, so the other reason one reason is that there's actually a really easy mistake to make in this algebraic method that we'll go over. In the factorization method, the other reason that it works better is because you can actually apply it to expressions that have more than one z term. So far we're looking at a z term and a number. Sometimes you'll actually have two z terms. So for example, z squared plus z may be equal plus 1. Right, so you won't be able to just solve that algebraically by rearranging it because there are two z's and they're not like terms. So that in this scenario, you would only be able to solve it by using factorization. So you might as well practice factorization from the get-go. Okay, so we'll go through both of them though, just so that you can have a bit of an exposure to each type of method. All right, so let's start with solving algebraically because, like I said, that's probably the faster method and the method that you might be a little bit more familiar with from, I guess, normal algebra. So to begin, we would move the 9 to the other side. We're trying to isolate z, get z by itself, so we would just subtract 9 from both sides, so we get z squared is equal to -9. Now, if we were solving this in the real plane, we would be, I guess, at a little bit of a, our problem would be finished because we can't square root a negative number. We can't continue to get z by itself from this point in the real plane. Luckily, because we're solving it over the complex plane, we can continue and we can actually square root both sides of the equation and proceed like that. Okay, so we've reached the point here. I'm going to put a big star here. This is our very common mistake position, which is the one that we were hoping to avoid. The common mistake here is that when we square root, we always have to remember to put the plus and minus. So you want to try to either really drill it into your mind that every time you square root both sides of an equation, you always have to put a plus minus there. Or if you are someone who will probably forget that and lose easy marks in an exam, what you should do instead is actually do the same problem by factorizing, and this way you'll actually never lose a solution. So the reason we do the plus or minus, we won't go over, but you have to make sure that you always put that there whenever you square root both sides of an equation. So that's why I would probably avoid this method, because that's a mistake that will definitely crop up in a lot of students' work. Okay. Other than that, let's continue. So we've got this little expression, plus or minus the square root of -9. So the great thing is we know from our surd laws that we can break up this square root into two surds multiplied together. So I'm going to bring out the -1 and the 9 as separate parts of that square root. And we'll just keep the plus or minus there. What that's actually saying is that there's two answers, one which is positive and one which is negative. So we've just got to keep that in mind. And now we're at a pretty nice point. We can simplify both of these surds. So the first surd, square root of -1, we can actually see over here, by definition, it's equal to this special letter I. So we're going to write, instead of square root of -1, we're going to write I. And then instead of root 9, well, what is the square root of +9? That's just 3, right? We already know that one. So simplifying that a little bit, our final answer is plus or minus 3i. So in other words, this is saying that there is one answer for z, which is -3i, and then another answer for z, which is equal to +3i. And you can verify that these answers are both correct if you wanted by substituting them into this expression here. So if you substituted -3i, that would become squared, and then it would simplify and add to 9 and equal to 0. So we're not going to go over that, but if you wanted, you can do that in your own time to verify that our working is in fact correct. All right, so this is the first method. Now the second method is first by factorizing over C, and then we're going to solve with the null factor law. So you should be familiar with factorizing quadratics from previous topics. So we'll start by writing this out again. Okay, so this one is a little bit tricky to factorize if you look at it straight away, because you can't seem to think of any, it's difficult to think of any quadratic factorization laws that apply to this. But what you can do is introduce a little hack. So we know that there is a special law called the difference of perfect squares, or difference of two squares, that looks like this. A squared minus b squared is equal to, and that factorizes to a minus b, a plus b. Okay, so from your quadratic equations, you should remember this really cool little law. So we are actually looking like we're very close to this scenario. We have the a squared, which is z squared, and we can even rewrite that 9 to be 3 squared. So we're very close to a squared minus b squared, but the only difference is that this is a minus and this is a plus. So in real numbers, again, we would not be able to continue here because this law requires it to be a minus. But because we are in the complex plane, we can pull this little hack where we introduce an I and make that into a negative. So what we do is we want that to be a minus, right? So I'm going to change it to a minus, but of course I can't just change it to a minus without doing something else. I'm going to also introduce an I squared into this expression. Okay, so this might seem a little bit strange, but the reason we can do that is because we know that I squared is actually equal to -1. So all I've done is I've broken up, so we know that this -1 here would cancel with that -1, and it would give z squared plus 9 as before. So all I've done is I've broken up this -1 into, I've broken up this positive into -1 times -1, and because of that, I'm able to rewrite one of them as just the negative, and I can rewrite the other one as I squared. So I hope you followed along with that. It's a little bit complicated when you begin, but you'll actually see this come up over and over again in complex numbers, where if you want to change a positive into a negative, all you do is you change it into a negative and just pop in an I squared, and that will counteract that that action that you took by making it negative. Okay, so once we've done that, let's rewrite this in a little bit of a simpler form. 3i squared. As you can see, all I've done here is I have just brought that I squared and 3 squared into one bracket to make the whole bracket squared. And now, voila, we are in the form of this difference of two squares. We've got the a squared minus b squared, and so now it's actually factorizable. We can continue from here. Okay, so what we can do is just rewrite, imagine that that's z. Maybe I'll do this like this. So imagine that a is equal to z and b is equal to 3i, according to the formula in this bubble that I've drawn. So all I have to do is then just substitute that into that rule. So instead of writing a squared minus b squared, we're going to write the one in brackets, a minus b. So a is z, b is 3i, and in the next bracket, a plus b, so z plus 3i. Okay, awesome. So now we're at a very good point in our problem because all that's left is we've factorized over c, tick to that part, and now all we have to do is solve with the null factor law. So solving with the null factor law, if you can remember, it just means equating each of the brackets to 0 and solving them separately. So I'm feeling like maybe we're running out of room, so I'll just make some space over here. If it erases. Give me 1 second. Oh, looks like we're not erasing. Pause that for a sec. Awesome, sorry about that. So we're just going to continue up here with that same problem because we've run out of space. I've just kept the answer from our rearranging version just so that we can compare and ensure that they're the same answer for both versions. So from here, we're just going to apply the null factor law, which, as I said, is equating each bracket to 0. So we'll break that up. So 0 is equal to this bracket, and 0 is equal to the next bracket, z plus 3i. Okay, so all you have to do here is rearrange each separate equation and solve for z. So from here it should be very easy because they will both be linear equations. So we just, in this one, move the negative 3i to the other side by adding it, so we'll turn into positive 3i. And in this one, we're going to move the positive 3i to the other side by subtracting it, so minus 3i. Okay, so that's our two answers for the factorization method, and as you saw, it did take us a little bit longer. However, we did completely avoid having to square root anything, and also this factorization method will also work for expressions that have 3 components, have 3 terms in them, whereas the rearranging one only works if there's just one z term in total. Okay, so I hope you followed along. Let us know if you have any questions, comment them on this video and we'll get back to you, hopefully explaining it a little bit clearer. And overall, fantastic work for following along. Thank you for watching through this video and we'll see you next time.